we've seen addition, subtraction, and multiplication of polynomials. Now we move on to division. Our approach is going to be fairly mechanical, so we'll start by explaining what division is, but our focus is going to be on procedures. Now, to start, okay, what is division? If I have quantity A divided by quantity B, okay, we call the answer C. What we're doing here, we're trying to find quantity C such that if I take B times C, we get A. So abstractly, this is all you need to know about division. These two statements say exactly the same thing. Now, if we do this with numbers, as usual, okay, if I take 24 divided by 3, well, I'm looking for a number such that if I multiply it by 3, I get 24. Okay, and you have your procedure for doing division. So the answer is 8, and we check our work. 3 times 8 is 24. If we took 25 divided by 3, okay, so this will be a little different because it doesn't divide evenly. Okay, our C in this case is going to be 8 plus 1/3. Okay, so here I'm trying to find the number times 3 that gives me 25. So it's going to be 8 plus 1/3. So if I check, I take 3 times 8 plus 1/3, I expect to get 25 back. Okay, so I'll get 3 times 8 plus 3 times 1/3, distributing. It's going to be 3 times 8, which is 24, plus 1. Okay, and then 1, because we're not dividing evenly, it's going to be what we call the remainder. So this is, okay, the abstract part. This is what we're trying to do with division. So the philosophy here applies when we use polynomials instead of numbers. Now, we're going to approach in stages. So first, we look at division by a monomial. Okay, so in that case, we're just looking at power of x times a number, okay, and there's no sums. So our denominator is just a single term. Then we'll consider long division. Okay, there we'll have no remainder, which means we'll have examples that divide evenly. Then finish, we'll look at long division with remainders. Okay, so there, that's the full picture. Now, before we go into this, let's recall the tools that we're going to need. So we'll need exponent rules. 3 rules that I need. Okay, x to the 0 is equal to 1. If I take x to the nth power times x to the nth power, we just add the exponents, so I get x to the n plus nth power. If I divide x to the m divided by x to the n, then I'll get x to the m minus n. First stage, division by monomials. Here we have a short checklist. The main idea is in the first step, which is to distribute our denominator, the monomial, into each term in the numerator. So this is going to allow us to write our fraction as a sum of terms in the form monomial over monomial. Then we can simplify each of those terms using the exponent rules. Finally, using the abstraction on the previous board, we could check our work. So we just take our answer, we multiply by the denominator, that's supposed to give us the numerator. Now, concrete example, take 2x cubed plus x squared minus 6x divided by 3x. Okay, for terminology, we call the numerator the dividend, the denominator the divisor. I distribute the 3x into each term, so we're going to have 3 terms in the sum. First term, I have 2x cubed over 3x. Numerical part's 2/3. I have x cubed over x, which becomes an x squared. Then we have x squared over 3x. I like to write the x squared as 1 times x squared, so it's clear what the number is. Numerical part is 1/3. Okay, so if I don't put the 1 in there, common error is to put the 3 in the top, giving us a 3, which would be incorrect. We have x squared over x, which goes to x, so I have a 1/3 x. Finally, I have a plus, and then I like to put the minus 6x in the fraction. So if there's more than one minus sign, they're all collected and easily cancel if needed. So I have a minus 6x over 3x. Number part goes to minus 2. The x's go away, and I have my answer. I can't simplify this anymore. For terminology, we call that the quotient. Now, we check our work. So we'll multiply this term, okay, this expression, by 3x. so I distribute the 3x to each term. 2/3 x squared times 3x. Okay, the 3's go away, leaving me with 2x cubed. 3x times a third x, the 3's go away, leaving me with an x squared. 3x times a minus 2 gives me a minus 6x. And we see that what's coming out agrees with our numerator, so that checks my work. Now, another example. If we have more than one variable, no problem. We follow the same procedure. For each term in the second step, we do the number part. Okay, say here the r part, the s part, and then put everything together. So we have minus 3r squared s plus 2rs squared minus 7rs over minus 6rs. I distribute the minus 6rs to each term. Okay, so our sum has 3 parts. Then we just simplify using our exponent rules. First term, the minus 3 and minus 6 become a half. R squared over r becomes r, and then the s's go away. Next term, I have a 2 over a minus 6, which becomes minus a third. The r's go away. S squared over s is just s. Finally, minus 7 over minus 6 is just 7/6. The r's go away, the s's go away, and then I have my answer. To check my work, we multiply by the denominator, so I have a minus 6rs. We see when we distribute, out comes our numerator. So that checks our work. Next stage, long division without remainder. So no remainder means we're dividing evenly. We have a checklist again. Okay, it's a lot longer, and this will cover the case when we have a remainder. The important part is the setup. So our setup is going to be the same as when we do long division with integers. We'll have our long division symbol. The numerator goes under the symbol. The denominator goes on the outside to the left. Because we're working with polynomials, I have to make sure they're set up properly. So we'll list our powers in descending order. So highest power, and then we work our way down. If we're missing any of those exponents, then we're going to fill them in with zeros. We'll need those for bookkeeping. Now, to actually do the long division, it's going to be like with integers, only a little bit different. Here, I'm going to consider the highest powers of the denominator and the numerator. I have to figure out what to multiply by to get from the highest power in the denominator to the highest power in the numerator. Put that above the bar, then I multiply the entire denominator by that term. I write that out under the numerator, lining up exponents. We negate, we multiply everything by a minus 1, and then we add. So that's going to guarantee that the first column goes away. We get a 0. We drop the next term from the numerator, and then we repeat the process. Okay, we're going to keep doing that till what comes out at the end has degree less than a denominator. So we're unable to match any further. Now, once we've done that, what's above the bar is the quotient. In our very last step, we'll have the remainder. Again, we can check our work. Answer times denominator is going to give us numerator if it divides evenly. If it doesn't divide evenly, we have answer times denominator plus remainder gives numerator. Now, we'll do a few of these. So first example, I take x cubed minus 2x minus x plus 2, divide by x plus 1. We set up our long division. Okay, so here we have numerator, here I have denominator. I have highest power x, here I have highest power x cubed. So to get from here to here, I multiply by an x squared. Now, if I multiply through here by x squared, I'm going to get x cubed plus x squared. We negate, and then we add. So I'm going to multiply through by a minus 1. Now, you can put the minus 1 in and go over the plus sign, but I like to put the minus signs either under slightly or somewhere where they're not in the way. So if I get an incorrect answer when I check my work, I'm going to need to do troubleshooting. I want to be able to track down every spot where I multiply by a minus sign. This makes it a little bit easier to look at. So we multiply through by a minus 1, we add. First column goes to 0. Second column, I have minus 2x squared, and then minus an x squared. So I get a minus 3x squared. Drop the next term, a minus x. Now I want to match this x to minus 3x squared. To do that, I multiply by a minus 3x. Okay, we put that above. I multiply x plus 1 by minus 3x. So I get a minus 3x squared minus 3x. We negate and we add. So I multiply through by a minus 1. These both become pluses. I add. First column goes to 0, so that checks. Minus x plus 3x goes to 2x. I drop the 2. Note, I can still match. So to get from x to 2x, I multiply by 2. So to multiply 2 by x plus 1, I get a 2x plus 2. We negate and we add. So I get minus signs. And when we add, everything goes away, leaving me with a 0. And then there's nothing I can match x plus 1 with to get to 0, except for 0 itself, so I stop. So what do I have? Our quotient, answer is x squared minus 3x plus 2. Our remainder is 0, which means we've divided evenly. Now, we check our work. So we're going to take our quotient, our answer. We're going to multiply by the denominator, the x plus 1, and then I expect to get our numerator back. So we have our answer, x squared minus 3x plus 2. Denominator is x plus 1. We do our multiplication. So I just rewrite the first line for the 1. For the x, we just increase each power by 1. Then when we add, we see what comes out is our numerator, so that checks our work. Stage 3, let's try an example with a remainder. So we'll have 2x cubed minus x plus 4 divided by x plus 2. We set things up. So I put in our division symbol. Denominator is x plus 2 off to the left. For the numerator, which goes under the symbol, I'll have 2x cubed. Okay, we're missing an x squared term, so I'll write that as 0x squared minus x plus 4. Exponents are all in descending order. Now, we want to match highest powers. So to go from x to 2x cubed, we multiply by 2x squared. So it goes above the bar. Multiply through, we have 2x cubed plus 4x squared. We negate, and then we add. First column goes to 0, second column goes to minus 4x squared. I drop the next term, so it's a minus x. Then we match again. So to go from x to minus 4x squared, I multiply by a minus 4x. That goes above the bar. We multiply through. I have a minus 4x squared and then a minus 8x. We negate, and they both turn to pluses. So plus and plus. We add. This column goes to 0. This column goes to 7x. Drop the next term. Comes down as a 4. We match. How do I go from x to 7x? We multiply by 7. So I get a 7x plus 14. Negate, multiply through by a minus 1. We add, I get a minus 10. There's nothing I can multiply x by to get to a minus 10, so that's where I stop. My remainder is a minus 10. Our quotient is going to be 2x squared minus 4x plus 7. Now, the way we write our answer, okay, let's remember what happens with integers when they don't divide evenly. So if I take 25 over 3, that's equal to 8 plus 1 over 3. So the way that we handle the remainder, we take our remainder and put it over the denominator. So that's how I get the 1/3 here. So in our answer, okay, we take 2x cubed minus x plus 4 divided by x plus 2. We'll take the quotient, 2x squared minus 4x plus 7. Then I'm going to add to that the remainder, a minus 10, divided by the denominator, which is x plus 2. Now, we want to check our work. So you'll note if I want to clear out this x plus 2, that's going to be the same as taking the denominator times our answer, the quotient, and then just adding the remainder, because the denominator will clear out here. So that's what we do. I multiply 2x squared minus 4x plus 7, the quotient, times x plus 2. Okay, so we multiply all of this out. I get 2x cubed minus x plus 14. We note that's not the numerator. If I add the remainder to this, minus 10, this 14 changes to a 4. I have the numerator, and our work checks out. Final example. In this case, we'll have a remainder, and we'll have to deal with fractions when we do our matching. So let's consider x cubed plus x squared divided by 2x plus 1. We set up our long division. So our denominator goes off to the left, 2x plus 1. Our numerator goes under the bar. So we have x cubed plus x squared, and then I have to put in zeros for the x term and the number term. So plus 0x plus 0. I want to match the 2x to the x cubed. So how do we do that? Well, to line up the exponents, I multiply by x squared. To go from 2 to 1, okay, there's a 1 out in front here for the numerical part. I have to multiply by a half. So I'm going to multiply by a half x squared. That goes up above the bar. We multiply through, so it's going to give me an x cubed plus a 1/2 x squared. We negate, put in the minus signs, and then we add. So first column goes to 0. Next column is x squared minus a half x squared, goes to a half x squared. Drop down 0x. We match the 2x to a half x squared. So to go from x to x squared, I multiply by x. To go from 2 to a half, we multiply by a quarter. Okay, if you need to work with fractions off to the side, 2 times a quarter is equal to a half. Now, that means I'm going to multiply by a quarter x. So we multiply through. I have a half x squared plus a quarter x. Negate, multiply through by a minus 1, and then we add. First column goes to 0. Next column is going to go to minus 1/4 x. Drop the next term, which is a 0. I want to match 2x to minus a quarter x. Okay, so x goes to x, so this is just going to be a number. To go from 2 to minus a quarter, I multiply by a minus 1/8. Okay, if I do work off to the side, 2 times 1/8 gives me a quarter. Okay, and then we put the minus signs in. So minus 1/8 goes above. We multiply through. I get minus a quarter x minus an eighth. We negate, which turns the minuses to pluses, and then we add. First column goes to 0. Next column gives me a 1/8. I can't match 2x to 1/8, so that's where I stop. So our quotient is above the bar, as so, and we have remainder 1/8. If I write my answer, okay, we're going to take x cubed plus x squared divided by 2x plus 1. We're taking what's above the bar as the quotient. And then we add to that our remainder divided by the denominator, so 1/8 divided by 2x plus 1. Of course, we check our work. So we're going to take our quotient, multiply by the denominator, and then we add the remainder. So we do that, quotient, denominator, multiply. Okay, we get this here, which is not the numerator yet. When we add the remainder, which is 1/8, that goes away, and then I have my numerator, and that checks our work.